Hello class, this is one of my first talks looking at fluid power, pneumatics and hydraulics. We're going to look at the sequence circuit first. This is something you're already familiar with, but I want to give you a reminder. So this is a simple sequence circuit. We've got two cylinders, cylinder A and cylinder B, both are double acting cylinders. Now they're controlled by directional control valves. These are 5-port, 2-position valves, and they're signal operated for both ways. Now the cylinders, we know the position of the cylinders because in the retracted stroke, this 3-port 2-position roller acted sprung return valve will tell a signal saying that the cylinder is in the retracted position, and when it goes forward it will signal to say the cylinder is in the forward position, and the same applies to this cylinder as well. Now the sequence is fairly straightforward. It's A plus, B plus, A minus and B minus. And we'll find, as you're already somewhat familiar, this sequence does run perfectly well. We have a service unit on the bottom which is supplying the air. So all of these symbols of the circles with the dots in are actually saying they are connected down to this manifold for a single supply from the service unit. We also have a 3-port 2-position button operated sprung return valve, and this is the one that we can use to initiate the circuit. Now the first thing of interest would be, where does the circuit complete its cycle? So in this case it completes its cycle at B minus. So B minus is the retracted position of this B cylinder. So at this point air is coming from this valve and is now going to initiate our operations. So I'll take the supply from this one. This valve is supplying air down and to the push button 3-port 2-position valve. When this push button is pressed, the top section of the valve will come down and visually replace this bottom section. So at this point, air is going to this point here, which would be port 1. It's going through the top of the valve here because this section has now replaced the bottom section, and the air is coming out. So air is coming out of here as we press the push button. Now this is now the start of the sequence. So at this point now, air is going up and is going to operate this directional control valve, which will also go across, and as it goes across, the air at this point is going up through into this line, and this cylinder is now going forwards. It's the first part of the sequence, A plus. As it goes forwards, it will eventually reach the end position, which is this valve. This valve will state that the cylinder A has now gone A plus in its forward position, and therefore the air at this point will pass through this top section as the valve is pressed down, and this will take us to the next operation. So the next operation would be to signal to the directional control valve of B cylinder. So B now goes forwards as well. So we've got two parts of the sequence completed. That's fine. So as B goes forward, it initiates and hits the positive forward stroke of this position. So this 3-port 2-position valve, the roller goes down against the spring and air goes through the top section and effectively is now coming out. As it comes out, this would be connected down and up to the A minus position. This 5-port 2-position valve switches back and allows the air visually, as we can see at this point, to go through and send the cylinder under pressure in the retracted stroke. So now A minus has also taken place. We're almost at the end of the sequence, so as A minus takes place, the last part would be the air from this point going through the top section because it's being pressed will come through, down, through, and we would connect it to this point here to send the valve back, so now B goes to B minus. It's the last stage, and B minus is now putting air back to the push button valve, and if we had the push button valve pressed continually, it would continue to cycle through here. But of course, if we were not pressing the push button valve, it would now stop at this point, waiting to start again as and when this push button is pressed. Now the thing about this sequence circuit is it runs very well. It runs conveniently. There are no issues whatsoever. But what we're going to find is as soon as we start changing sequences, often things just do not work. And when they don't work, we have a problem called trapped signals. And one way of eliminating trapped signals is to use a cascade circuit. There are many other options, but I really want to look at how to identify the trapped signals and then how to implement cascade circuits to eliminate the problem so very complex sequences can run. So what I will do initially, I'll remove this and we'll re-look at this again one more time with a very quick change to the sequence. So I'll remove this sequence and I'll replace it with A plus, B plus, B minus, A minus. So I've swapped the sequence around slightly. The last position is A minus. So at this point, A minus has been pressed on this 3-port 2-position valve and the air is now readily available to the push button. So we're back to where we started. You press the push button, and when you press the push button, it operates the directional control valve. The valve goes over, air goes through this part diagonally, and the cylinder goes forward. A plus has been achieved. A plus now hits the forward position. At this stage, air goes through this valve and it operates as prior this directional control valve, which switches across, and B plus also goes forwards. So far so good. However, as it goes forwards and hits this valve, the next stage would be B minus. So if we were to draw this into the circuit, this goes down and onto B minus. However, remember, A plus is already in position, a signal is already present at this stage, so now we have two signals, and this signal cannot dominate the operation because it's held on with an equal force on this side. So at this point here, we have a trapped signal taking place. But we'll forget about it just for a moment. We'll assume that B does go back. So at this stage, B minus retracts, and as it retracts, it sends the signal down here up to this stage here for A minus. It retracts, the signal is on, it's held in this position, holding the signal on. This is now saying I'm in A minus, and because I'm in A minus, I can now continue with the sequence and it goes through to this point. But yet again, we have double operations, another trap signal problem. So now we have yet another problem at this stage. Now we have to remove trap signals. You can use impulse timers, you can use specialised equipment, or you can use a technique called the cascade system, and it can be used for simple circuits and more complex circuits. One thing to note at this point is this. We could safely say that that part of the circuit from there to there runs correctly up to the problem. And we could say actually that this part of the circuit runs correctly up to the next problem. So on that basis, it would be easy to say and achieve this point. If the air on this side was separated from the air on this side, so we'll call this group 1 air, which operates A plus B plus, and then group 2 air that operates B minus A minus, if we had separate air supplies, group 1 air could operate A plus B plus, and then if you terminated that air, you would also take away the trap signal. Consequently, if you brought new air on for the sequence that is now going to follow, it would allow it to operate up to the trap signal. If you remove G2 and then reinstated G1, then you would remove again the trap signal. So the cascade circuit is a way of having separate air supplies, and when they reach a problem, such as trap signals, they eliminate everything prior, including the trap signal, and they bring new air on yet again for the next part of the sequence. And you can do this continually. So in the next video, I'm going to show you how to do this circuit very straightforwardly with a cascade method. And then after that, I'm going to show you how to do a more complex circuits that you need to do using the cascade method, but using more cylinders. So my next video will cover more and more in depth, and eventually my other videos will cover hydraulics, regenerative circuits and other aspects that you need to know. But for now, thank you for listening, and I'll see you on the next video.